Hi everyone. Okay, so we are going to be starting our next video, video 11, where we're going to be looking for only the domain using an equation as opposed to looking at a graph, which is what we've been doing up till now. And this is in section 14C.2 in your textbook. Okay. So very quickly we're going to go past the opening problems and we'll go straight into the lesson. So, like I said, basically what we've done so far is we've found the domain of a function by looking at the graph. Now we're going to be looking at finding the domain of a function by using or by looking at an equation. So we're going to be looking at it algebraically. Now, when we're looking for the domain of any function, what we are doing is we're looking out particularly for two things. The first thing we look for is to make sure that we don't have a zero in the denominator of a fraction. So one restriction or one thing that we're looking for is no zeros in the denominator of a fraction, which makes it undefined. We already talked about this in class. And the second thing that we also want to look out for is we don't want to have any negative numbers that are under square roots. So these are always the two things that should be in the back of your mind as you are working out these questions. These are the two specific restrictions that we are looking for. No zeros in denominators and no negative numbers under square root signs. Alright, now let's suppose that we had this problem here where it says find the domain of the following function. So I have f of x equals 1 over x minus 2. Now the denominator cannot equal 0. As soon as I see a value of x in a denominator, I am automatically going to say, oh, the denominator is not allowed to be equal to 0. So what I do is, in order to figure out what values will bring the denominator to 0, I set it equal to 0. I take the entire denominator and set it equal to 0. So in this case, it's really easy because I know that I can just look at it very quickly and say, well, 1 over x minus 2, the value of x must go to 2 in order for the denominator to go to 0. Therefore, the number should be 2. Now, the way that I would do that algebraically, though, is I would just take my entire denominator and I would set it equal to 0 so that I get x equaling 2. That x equaling 2 is the value that needs to be removed from the domain. That's the one value that the domain is not allowed to be. It is not allowed to be equal to 2. So that when I replace it now, or when I write it in set notation, then in set notation I will say the set of all x is such that x is an element of R, and that x cannot equal 2. And if I put that then either or, if I put it into interval notation, then in interval notation I have the domain is equal to round parentheses negative infinity to 2 union from 2 to 0, where you notice that the number 2 is not being included because we have round brackets on both sides here. So the number 2 is not included. Okay. Now, let's assume now that we've got the next question here. And now I'm saying that the denominator is not allowed to be equal to 0 again, because except this time I've got a quadratic in the denominator. So I've got a quadratic function. So what I do is I set the denominator equal to 0 to figure out where it is that x is not allowed to be. So when I look at it and I say x squared minus 7x minus 30 is equal to 0, I can use the sum and product, if you recall. So what two numbers multiplied together give me negative 30, and added together give me negative 7. And so that I find out that the numbers are negative 10 and 3. So then I use my null factor law as we had done last year, so that I can say either x minus 10 is going to be equal to 0 or x plus 3 is equal to 0, so that I know that x equals 10 or x equals negative 3. Those are the 2 points where I know that x is not allowed to be where it goes to undefined, my denominator. So in set notation, I will write it as x is such that x is not allowed to be equal to negative 3, and it's not allowed to be equal to 10. If I write that in interval notation, then in interval notation, it will go from it is allowed to be from negative infinity to negative 3 included. Sorry, negative 3 not included, with the union of negative 3 to 10, and then union 10 all the way to infinity. Everything has here round brackets on it. Okay. The next one. Now, when we look at the next one, we have g of x is equal to the square root of 2x plus 3. Now, in this particular case, we're going to have to use an inequality, because we said that with the inequalities, or with the square roots, whatever's under the square root must be greater than or equal to 0. Okay? So what I do is we take the 2x plus 3, which is underneath the square root sign. We take our 2x plus 3, and we set it greater than or equal to 0, and we solve it as if it were just a regular equation, so that I get 2x is greater than or equal to negative 3, x must be greater than or equal to negative 3 over 2. So that in my set notation, it's just going to be the set of all x, such that x must be greater than or equal to negative 3 over 2. Or in interval notation, I'm going to include negative 3 over 2, so I'll have a square bracket, and that'll go all the way to infinity, round bracket. Okay, so that's how we are solving these. So I hope that it's understood at this point. I hope you're seeing the pattern, that what I'm doing is I'm setting things either equal to 0 or greater than or equal to 0, depending on what the question is asking, in order to figure out what x is not allowed to be. Okay? All right. Now, here's one that is a bit more complicated, where we're looking for the domain. So we've got the f of x is equal to the square root of x minus 1, all divided by x squared plus 4. Okay, now, I've got x in both the numerator and the denominator. Okay? And the one thing that I'm looking at immediately is my denominator, and I say, well, I've got x squared plus 4. Now, I am not allowed to have 0 in a denominator, but when I take a look at it, I notice that there is no value of x there that will ever bring my denominator to 0. So I can say that I have my domain so far is that in the denominator, x is an element of R. So I know that in the denominator, x is an element of R because there is no value of x that will ever make it go to 0, because all my values of x here will always go to a positive. And I know that my values of x will go to a positive simply because x is being squared. So even if I put a negative number and I square it, it's still going to be positive. So if I do negative 4 and I square it, it'll go to positive 16. 16 plus 4 is 20. If I put negative 2 and I square it, it still goes to 4. If I put 2 squared in there, it still goes to 4. So there is no number in there that's not going to work. And if I placed 0 in there for x, I'd still have this all going to 4, because 0 squared plus 4 is 4. Now, the other possible restriction, though, so I know that the denominator is not a restriction. So I can say x is an element of R there, so I have no worries. The only thing that I need to be concerned about is that I've got the square root of x minus 1 in the numerator, and the restriction in the numerator is that I cannot have a negative number under the square root sign. So in the numerator, I'm going to have to use an inequality and say x minus 1, here it is, I'm going to have to say that x minus 1 has to be greater than or equal to 0. I am allowed to have a 0 in the numerator. I can have the whole function going to 0. I just can't have the denominator going to 0. So that I can say that x must be greater than or equal to 1. Okay, so in set notation, that means x is such that x is greater than or equal to 1, or square bracket in interval notation, square bracket 1 through to infinity, with the comma in between, where infinity then will have a round bracket. Okay, now, they start getting a little bit more complicated as we move along. So let's take a look at this next question, where I have f of x is equal to 1 over the square root of x squared minus 4. Now, in this particular question, I have two things occurring simultaneously here. I cannot get a 0 in a denominator, and at the same time, not only can I not get a 0 in the denominator, but I can't get a negative number under the square root sign either. So both things cannot occur under there. Alright, so because the only thing I can put under here then is that I have that it's greater than, since we can't have a 0 in the denominator nor a negative number under the square root. Okay, so if I say x squared minus 4 is greater than 0, okay, now we can factor a quadratic expression to obtain. So if I factored that, x squared minus 4, that would go to x minus 2 times x plus 2. Okay? But we can't use the null factor law because this is an inequality. It's not an equation. I can't just say, well, either x minus 2 is greater than 0 or x plus 2 is greater than 0, and therefore x has to be greater than 2 or x has to be greater than negative 2. Okay? That can't be done because it's an inequality. I can only do that when I have an equation, when I have just an equal sign. So what we have to do at this point is we need to use a sign diagram, something that we called a sign diagram. Okay? And we use a number line and we mark the possible values of x for which the expression could be equal to 0. And we know that the expression where it could be equal to 0, the numbers would have to be 2 and negative 2. Alright, now, so what I start doing is I start placing here negative 2 and 2 on my number line. And now what I need to see in using the sign diagram is in each subinterval, so between negative 2 and negative infinity, between negative 2 and 2 and infinity, I need to know what's going on with the graph. So is it positive or is it negative? Like what's happening with those values? So what we can do is we can actually pick some test points. Okay, so what does that mean? So if x were less, starting with the left-hand side here, if I were to pick a number less than negative 2, I just happen to choose the number negative 10. Okay? If I take that and I replace it back into the equation, x squared minus 4, I'm circling it right now in blue up at the top. If I take the value x equals, so the test point chosen was to figure x was equal to negative 10. If I make x equal to negative 10, then we're looking at the graph from the left-hand side. So we're looking to see what's going on. So just up here, if you take a look at the graph, I'm looking to see what's happening up here when I've got values less than negative 2. So I chose negative 10. And when I put negative 10 into the inequality that I circled up here, x squared minus 4 is greater than 0, I ended up getting negative 10 squared minus 4 is greater than 0, and 96 is greater than 0. And that's true. So I make that as a positive. When it's true, then I say it really means that it's positive. If I now choose, looking at my number line again, a number between negative 2 and 2, well, I'm going to pick the number 0 simply because it's the easiest number to pick. So I pick 0 and I replace it again back into the equation x squared minus 4, inequality rather, x squared minus 4 is greater than 0. So that I have 0 squared minus 4 is greater than 0, negative 4 is greater than 0, that's negative. It's a false statement. Okay? And then I do the last one, where x is greater than 2, so I'm just going to choose 10, but I could really choose any number greater than 2. And I end up getting, again, that 96 is greater than 0, so it's positive again. So the areas where it was positive were from negative 2 to negative infinity and from 2 to infinity. That is what our domain is. Okay, so we choose the positive portions on the number line to show what our domain is going to be. So if I were going to do this now using set notation, I would have to say that x is going to be less than negative 2, or x has to be greater than 2. And the numbers in between, negative 2 and 2, are not on that graph. They are not included. Okay, they cannot be equal to 0. Okay, they cannot be equal in this case. Now, it's only greater and not equal, simply because if it's equal, this whole thing goes to 0 in the denominator, and I don't want that. So I'm going to have to say x squared minus 4 is greater than 0. So that's why I have open circles here that have not been colored in, and that's why we're not putting the equal sign underneath here as x is less than or equal to, or x is greater than or equal to. It's just x is less than negative 2 or x is greater than 2. Now if we're going to be using interval notation, then it'll go from left to right, from round bracket negative infinity to negative 2, union from 2 to infinity. Okay. Now, we have a follow-up question that I am not, that you are supposed to be doing on your own, and there it is. So I want you to work on, you'll be working on this question in the video, and so that way we can, so I can see whether you guys are getting this or not. Okay, next. Oops, went too fast. Okay, so let's do another example where we've got a domain and where we're looking for the domain and we're writing it in interval notation. So I've got f of x is equal to 3x minus 9 over x squared minus x minus 2. So I immediately look at my numerator, and there is no restriction on the numerator. There is no square root sign, and there's no denominator on it. So I can disregard it, and I know that up here x is an element of r. So I don't even need to worry about this up here, okay? But down here in the denominator, I know that my denominator can't go to 0. Okay, so what I do is I set it equal to 0. So I say x squared minus x minus 2 is equal to 0. And when I factorize, it goes to x minus 2 times x plus 1 is equal to 0, so that I have x is either equal to 2 or x is equal to negative 1. So that tells me that the two values that make this entire function go to 0 are 2 and negative 1. So my domain is going to be in interval notation, is that they are not allowed to be equal to negative 1, and they are not allowed to be equal to 2, the values of x. So that I will start from my left-hand side, and I will say from negative infinity to negative 1, not included, okay, and I can do a union with from negative 1 to 2, because the numbers in between them are included, and then I do a union with 2 to infinity. This is telling me that the values in between of negative 1 and 2 are not included. So negative 1 and 2 are not included, but all the other numbers are. Okay. Now, just to very quickly, we haven't talked about, look at this, we haven't talked about range. We've only talked about domain. Now the reason for that is because it is much more difficult for us to find the range using algebra unless we know what the actual domain has been given to us. So if I just give you an equation such as this, f of x equals 1 over x, okay, because I don't know what the possible values of the x are, I can't really just determine what the values of the y are just from doing it algebraically. So the range, if you are ever asked to figure out what the range is, given just the function, or just given 1 over x, for example, in this case f of x equals 1 over x, then what that means is that you are going to have to go to your calculator and graph it and then read it off of the graph. This is only with the range. So the domain we can figure out without any problem doing it algebraically. The range is a bit of a different story. You need to open up your calculator and you need to graph the function in order to figure out what the range is. Okay, so we'll talk about that in class. We'll do some examples of that in class. Okay, and again, we could also see it, by the way, we would also be able to see it if we looked at a table where we have an error. So if you looked at an error, then the error would show that place where your value of the y is not allowed to be. Okay? So again, we'll talk about this in class. Okay, and then we'll talk about these questions further in class. The very last thing is just to complete exercise 14C.2, which will all be done not as homework, but it'll be done as classwork. And I will be checking work in class. Okay, and you also have a handout called Domain and Range Algebraically to be complete. Okay, that's it, and see you next time.